Good morning, everyone. Today we will see the topic largest subarray sum problem in design and analysis of algorithms. First, we will see what is largest subarray sum problem. Here, the problem is to find the maximum sum of contiguous subarray elements of the given array. The subarray should be contiguous. Input is given one-dimensional array A of size n elements. The array A contains n elements. The elements can be positive or negative values. So input is only array A with n values. And the problem is to find the subarray. And sum of elements in the subarray should be maximum. If you take any subarray from the given array, and find the sum of elements, that should be maximum. That is called largest subarray sum. Largest sum of subarray, that is the output of this algorithm. So output is the maximum sum of contiguous subarray. The array element should be in continuous. Should be continuous. So the sum of elements in the subarray should be maximum, should be the largest. That is called largest subarray sum problem. We will see one example. Here the array A is input, which has negative values and positive values. We are going to find out the contiguous subarray of numbers, and the sum of elements should be maximum. That is largest sum of subarray. And you take the example. Here there are 7 elements, and the subarray, it takes only 3 elements from the given array. All the elements should be continuous. It's a contiguous subarray. Add these elements, 5 minus 2 plus 4. So 9 minus 2, 7. The sum of subarray is 7. That is the maximum. That is the maximum value for a given array. That is, if you take any subarray from the given array, that sum of elements in the subarray should be maximum. Largest sum of the given subarray. That is the problem. The output is 7. So here we are finding only the largest sum of subarray. And we will see 2 more examples. First example, so take the subarray 4, minus 1, minus 2, 1 and 5. So add these values, 6 plus 4, 10, 10 minus 3, 7. 7, that is the largest sum of subarray. If you take any array other than this, if you take any subarray from the given array, the sum of elements in the subarray should be, that is lesser than the value 7. So this subarray gives the maximum value than other subarray. That is called largest subarray sum. And take the second example. So we have 7 elements. The first 5 elements, sum of first 5 elements, that is a subarray 5 minus 2 minus 1, 4, 6. That is 6 plus 4, 10 plus 5, 15 minus 3. That is 12. 12 is the largest sum of subarray. If you take any subarray other than this from the given array, that gives only lesser value. That is, which is lesser than 12. So this is the subarray whose sum of elements is greater, that is 12. All the elements, the important condition is all the elements in the subarray should be in contiguous order. So this is the problem. Next, we will see how it works. This is a working of largest subarray sum. This is a navy approach. This is a brute force approach, how it works. So take the array A. There are n elements, index from 0 to 6. And there are 2 formula. So we are finding the current max. Max equal to current max plus A of I. So A of I is the array element. So we are taking array element 1 by 1 linearly from 1 to 6. And so that is A of I. So comma A of I. So we are finding current max is maximum of current max plus A of I and A of I. So now max so far is equal to maximum of current max. So previously we found the first step, we found current max. that is compared with the max so far in the previous step. So whichever is maximum, that is assigned as max so far. So see this example. So we have a loop variable I. Initially I equal to 0. This is a linear approach. We are taking elements one by one from the first. So take the first element A of 0, 5. Initially that is assigned as current max and max so far. Initially the array first value is assigned as current max and max so far. Next I equal to 1. The next value. What is A of 1? Minus 2. Now, see how to find current max. So, what's the formula? Maximum of current max. The current max is previous step 5 we have. So, what's the array value? Minus 2. So, current max plus array value. So, 5 minus 2, comma array value. That is minus 2. So, 5 minus 2, 3. 3 comma minus 2. The maximum value is 3. Now, in this step, we are getting current max. Then, how to find max so far? That current max is compared with the previous step max so far. Find out whichever is maximum. So maximum of 5. 5 is max so far in the previous step. Comma 3. 3 is current max in the current step. So 5 comma 3 maximum is 5. Next go to the second iteration. I equal to 2. So A of 2 is minus 1. So how to find max? Max is equal to, there is maximum of 3. That's the previous step current max. That is 3 minus current array value. 3 minus 1, comma minus 1. So the maximum is 2. 2 is the current max. That is compared with previous max so far. That is 5. So compare 2 and 5. The maximum is 5. That is the second next step max so far. So like this, we are doing for n minus 1 steps. N minus 1 steps. So each step we are finding current max. That current max is compared with max so far. So maximum of current max and so far is the current so far. So that is the 12 value. The last step we have 12. So 12 is the largest subarray sum. So which one gives 12? Take this example. Which one gives 12? So here, take the value 4, 6. That is 6 plus 4 is 10. Take the first value, A of 0, 5. So 15. In between 2, we have 2 values, minus 2, minus 1. So first value, A of 0 to A of 4. First 5 value is the result. 5 minus 2, minus 1, 6 plus 4. This totally we have 12. 12 is the largest sum. This is based on Navy approach, brute force approach. Then this is the algorithm for Navy approach. So what is that? Input is A of 0 to n minus 1. Array A contains n elements. Output is the largest sum, the single value largest sum of contiguous subarray. So first input array A. So initially we are assigning current max and max so far is equal to A of 0. First value is assigned as current max and max so far. And start the loop from I equal to 1 to n minus 1. So how we are finding current max? We are adding current A of I value. We are comparing A of I value with current max plus A of I. So whichever is greater assigned as current max. Then if that is array value is not greater, so assign current max plus A of I as a current max. So the same first formula is implemented in step 5. Then how to find max so far? So we are comparing current max with max so far. Whichever is greater, that is assigned as max so far. So this process is repeated till n minus 1. So finally, the value of max so far is the final largest subarray sum value. Here, the time complexity of brute force approach, Navy approach is order of n square. Next, we will go to divide and conquer approach. How the time complexity is reduced from order of n square to some value that we will find out. Next, how to solve largest subarray sum problem using divide and conquer approach. Normally, what is divide and conquer approach? There are 3 steps. Divide, conquer or solve, then combine the result. Divide, solve, combine. So that is the main important step of divide and conquer approach. Initially, the given array is divided into 2 equal parts. So this is a recursive algorithm. Recursively, the input array is divided into sub-arrays till we have a single element. That is the first step, divide step is over. After that, find the maximum sub-array sum for left half. For the left half, you are finding the largest value or maximum value, and find the maximum value for right sub-array, then combine the result. Then here we are going for crossing sub-array. Why we are going for crossing sub-array means the second step, we are finding the largest sum sub-array from left part. So sub-array, maximum sub-array can be in the left part, or it can be in the right part, or it can lies between left and right. So the subarray can be in anywhere. That can be in left, either left or either right, or in between. That includes some element from the left and some element from the right. So we are finding cross subarray also. So here we have three formulas: LSS, RSS, CSS. LSS is largest from left subarray. RSS is large value from the right subarray. And CSS is crossing subarray. Some we are finding the middle value, then find the CSS value. So that is next step. So we are finding three values. And the fifth step, we are finding the largest value of current array, that is max of LSS, RSS, CSS. So we are finding LSS, RSS, and CSS in step 2, 3, 4. So find the maximum of these three value. That is the largest sum for this current node. So this process is repeated till we get largest value for the root node. Root node is the final problem. So we are finding the largest value for the root node for the given array. So that is the final answer. So this is a recursive algorithm. So here we are dividing the input array into sub-arrays till single element. Then find out LSS, RSS, CSS. Then find the maximum of these three value. So that is the largest value of the current node. So this process, that is finding L, is continuously processed till we have a largest value for the root node or for the given array. That is the concept of divide and conquer approach for finding largest sub-array sum. And see the example how it works. So initially we have 8 elements. Divide into 4, 4. Again divided into 2, 2. Again divided into 1, 1. So first division step. So the given array is divided into n by 2 sub-arrays till we have a single element. That is see the last level, that is single element. That's a leaf node. -2, -3, 4, -1, -2, 1, 5, -3. These are the nodes in leaf level. And so how to find L value for the sub-array? So here in this approach, we are finding the solution for sub-problem from the bottom. Then we are going to the next level to the top. The next level, we are moving from bottom to the top. So we are combining the solution of sub-problems to get the solution to the original problem that is in the root node. So from the bottom, we are solving. So see the last level. So each level, our aim is to find L value, that is largest sum of sub-array. And here we have only one node, single node, that is the largest value. So take the single node value as it is, that is the L value. That will be sent to its parents node. That is the original problem. So see the first step, -2, -3. So largest of left subarray -2 is -2. Largest of right subarray of -3 is -3. Because it's a single element that can be considered as the largest value. Next, -2, -3. So now we are going to find capital L value for this node. So to find capital L, we need three values: LSS, RSS, CSS. So LSS is largest of left subtree, that is -2. RSS is largest of right subtree, that is -3. So L is considered as a LSS for the parent node. L in the right side, L is -3, that is considered as the RSS, solution of right subtree for the current node, -2, -3. So then how to find CSS? Here we find the midpoint. Before the mid, we have only one element. After the mid, we have only one element. So consider there is a maximum in left, there is a maximum in right. So how to find CSS? Sum of maximum in both sides. So minus 2 plus minus 3, that is minus 5. So find out L value, capital L value. For each node, we are finding LSS, RSS, CSS. So find the maximum of these three values assigned to L, that is the largest subarray sum for the given subarray problems. Again, this process is repeated for 4, minus 1, minus 2, minus 1 at this level, all the nodes at this level. Again, combine the solution for minus 2, minus 3, 4, minus 1. Then combine the solution, the root node. Okay, how to find CSS? If we have more than one element. Okay, see the steps minus 2, minus 3, 4, minus 1. The subarray problem. Left side subarray problem, minus 2, minus 3, 4, minus 1. So what is the LSS value? That is solution of left subarray. That is minus 2. That is LSS for the node. Then what is RSS for this node? That is solution of, that is largest of right subarray. That is L equal to 4. That is the RSS value for current node. Then how to find CSS value? So take the midpoint before the mid. First half subarray, start from before the mid. So minus 3 write as it is. Again minus 3 is added with next element minus 2. So minus 3 plus minus 2 is minus 5. Now next go to the right side. After the mid we have 4. Write as it is, the top 4. Again 4 is added with next element 4 minus 1 3. Now we get all the values. So take the maximum. The star represents the maximum in left part and the next star represents the maximum in the right part. So here in the left side minus 3 is maximum. So minus 5 minus 3. So maximum is minus 3. And the right side 4 and 3 maximum is 4. So add these two values 4 minus 3. Add maximum in both sides. Minus 3 plus 4 is 1. Now we know the CSS value. So find out the maximum. L equal to maximum of minus 2, 4, 1. The maximum is 4. Again, this process is repeated for right subtree also. Then find out the L value for the node. So we know the largest value of left subtree, that is L equal to 4. For the root node, I am telling. For the root node, the solution of right subtree is 6. That is RSS value for the root node. So LSS value is left side solution 4. RSS value is 6. Then how to find CSS value? So find the midpoint, split the array into two points. Take minus 1 before the immediate element. That is minus 1, right as it is. Minus 1 is added with the next element. That is minus 1 plus 4 is 3. Again 3 is added with the next element. Minus 3, 0. Again 0 plus minus 2 is minus 2. So what is the largest value? See the root node. What's the largest value in the left side? Minus 3, minus 1, 3, 0, minus 2. 3 is the largest element. In the right side, so take minus 2 as it is. Minus 2 is added with the next element. Minus 2 plus 1 is minus 1. So minus 1 plus 5 is 4. 4 minus 3 is 1. So what is the maximum in the right side? 4. So left side 3, right side 4. That is star is given. That is maximum in both sides. So add these two values, 3 plus 4, 7. That is CSS value. Now find out the L value. That is maximum of LSS, RSS and CSS. 4, 6, 7. So maximum is 7. So the root node L value is the final result. That is the largest subarray sum for the given problem. So this is the divide and conquer approach. Here I am showing that the intermediate steps, how to find CSS value for intermediate steps. So we have minus 2, minus 3, 4, minus 1. So we know the value LSS is left side largest value, that is taken from left child, and RSS value is 4. 4 is taken from right child. That is L value. Largest of right side is LSS. Largest of left subtree is LSS. So we know LSS and RSS. How to find CSS? So CSS is equal to sum of max in both sides. So how to find max in both sides? Split the array into two parts. Before the mid, immediately we have minus 3, right as it is in the top. Again minus 3 is added with minus 2. That is minus 5 is the answer. Here the 4 is right as it is. 4 minus 3, minus 1 is 3. So minus 3 is the largest in the left side. 4 is the largest in the right side. So add these two values, 4 minus 3, 1. That is the CSS value. So how to find L? Maximum of LSS, RSS, CSS. That is maximum of -2, 4, 1 is 4. That is the largest value for this node. And the case B is to find CSS in last step. That is for the root node. Okay, already we discussed. Again, I'm repeating how to find CSS. That is because finding CSS is the important calculation for finding the largest value. So we have 8 elements. Divide the array into 2 parts. Before the mid, we have -1. Take right in the top as it is. So -1 is added with the 4, that is 3. 3 minus 3 is 0. 0 minus 2 is -2. So left side largest value is 3. And the right side, take after mid, right, see -2. Write the same value above. This -2. That is added with the next element. 1. So -2 plus 1 is -1. Again -1 plus 5 is 4. 4 minus 3 is 1. So the right side 4 is the largest element. So find out the maximum of LSS, RSS, CSS. So LSS is 4, RSS is 6 and CSS is 7. So maximum of these three value is L equal to 7. This is the largest value for the given array. The root node. Given array root node in the last step, that is 7. So 7 is the final result of the given problem. And so how to write C program for finding largest subarray sum using divide and conquer approach. So see that int main function. So main function we declared array A, n is size of the array and I is a looping variable. So first get the size from the user, that is n value. Then the function is called for getting n elements for the given array. So input array, so get n values from the users. Then print largest subarrays is equal to %d, comma, we are calling the functions max sum subarray function. This is a function called, we are calling another function by passing 3 parameters. A, this is array, 0 is the starting index, n is the final index. So we are passing 3 elements. And see here, this is a max sum subarray functions. So it has array A. So the low is the first limit. High is the last, points the last element. If high equal to 1, if high equal to 1, if the array has only one element, return a array of I, that only one element, that is the largest element. And if we have more than one element, so first condition is for any recursive call, the first statement is the termination statement. When the recursive call will be terminated, this is a recursive function max sum subarray. See, within this function there are two recursive call that calls the same function. So if you write recursive algorithm, first statement should be a termination statement when the algorithm will be terminated. So high equal to low. So if array has single element, high equal to low means there is a limit index. It points the same array elements, means that is array has only one element. And so if array has more than one element, find the midpoint, that is high plus low by 2. Then what's the, so here we are splitting the array into multiple subarrays, still we have single element. Again find the solution for the subarray, combine the result. Again find the largest, combine. So that will be processed till the root node for L. So here array, we are splitting into 2 parts. Array, for 2 parts, we are finding maximum only. So we are calling the same function for left side, and we are calling the same function for right subtree also. So it calls itself. So max sum of subarray is array low mid. The second subarray is array mid plus 1 to high. So this is the dividing part. And max crossing subarray, that is the input. This is a function called for another function that we will see. Finally, return maximum left subarray and maximum right subarray. That is where we are having LSS, RSS, and maximum crossing subarray CSS. The last statement is maximum of LSS, RSS, and CSS. That is maximum function. And we will see what is maximum function. So we have 3 elements A, B, C. How to find maximum? First, compare 2 elements. If A is greater than or equal to B, this is the greatest of 3 numbers, the same code. If you are giving A, B, C, three elements. Find which one is greatest. There is greatest of three numbers, same code. If A is greater than or equal to B and A is greater than or equal to C. If A is greater than both B and C, return A is greater. Now, when the if condition is false, if A is lesser than B or C. So in that case, we can omit A. The else if we are comparing only B and C. Because the first case, if A is smaller, that is failed. So if A is small, we are going for B and C. So we are comparing B with B is greater than or equal to A and B is greater than or equal to C. Return B, else C is the greatest element. This is the greatest of three-number code. Again, there is a maximum. So this is the C is largest. We are finding A, B, C or CSS, LSS, RSS. That is return C is the maximum element. And max crossing subarray. So initially we are assigning some very most negative value to the left sum. So in sum is equal to 0 int I. So this is a code for finding largest of crossing subarray. So we are finding the mid value. Before the mid, we are adding elements one by one and we are finding the maximum value. And for the right subarray also, we are assigning most negative value. Initially, we are assigning sum is equal to 0. Again, the second part closed for loop for I equal to mid plus 1 to high. That is the second subarray. And take the first element as the sum, add the sum with next element till we reach the last element. So take the maximum, whichever is maximum, that is assigned as right sum, that is RSS. And so after finding LSS and RSS and CSS, we can go for finding the maximum. That is the maximum function is executed. The value, the largest of subarray sum is returned. So this is the output. Then the size of the array 8. I am giving the same input -1, -3, 4, -1, -2, 1, 5, -3. The largest value is 7. Largest of subarray is 7. Already we discussed what's the subarray for this problem. So this is the output of algorithm. So here we are using divide and conquer approach. There are n elements. Each iteration number of inputs reduced by half, that is n by 2. Again n by 4, n by 8, like that it will go. And so when this is a recursive algorithm, so T of n is to find the largest subarray sum. Recurrence relation is T of n is equal to 2 T of n by 2. Again, T of n by 2 is input means 2 T of n by 4. Like that it will go. If you solve this equation, we are getting T of n is equal to n log n. So compare this n log n. There is a divide and conquer approach for finding the largest subarray sum. And the first one is brute force approach. In that it takes n square. So n log n value is lesser than n square. So the time taken by applying divide and conquer approach is lesser than using the approach brute force approach. So there is order of n log n. So divide and conquer approach is better. It takes minimum time than the brute force or navy approach. Thank you.